Hello and welcome back to the Cracking FAANG YouTube channel. Today we're going to be solving Leetcode problem 341, Flatten nested list iterator. You are given a nested list of integers, nested list. Each element is either an integer or a list whose elements may also be integers or other lists. Implement an iterator to flatten it. We'll need to implement this nested iterator class, which will initialize our object with the nested list. We need to implement a next method, which returns the next integer in the list. And we also need to implement a hasNext method, which will return true if there are some integers in the nested list and false otherwise. This is just how the code will be executed. No need to read that now. And let's just look at a very basic example. So if we're given our nested list is a list containing the list 1, 1, the number 2, and then another list 1, 1, we want to flatten this, right? So we would take this first list, we'd flatten it into 1, 1, then we get to the 2, that's already a number, we don't need to flatten anything, and then we get to the last one, which is 1, 1, we just flatten that. So our final answer is 1, 1, 2, 1, 1. We've essentially just flattened it, which you can see is the output here. Okay, example 2, we have 1, 4, 6. Obviously, this is a list, and then there's also a nested list in here. So the way we'd process it is just do the 1, and then we get to this list here. So we need to flatten this part. So this would become a list of 4 and 6. And then we can just grab the 4, and then we need to flatten this 6 as well. So we would do that and continue for 6. And there we go. So those are the basic examples. As you can see, it's relatively straightforward. Just the way that we implement this can be a little bit tricky, but let's kind of wipe away all this text here and just look at one of the examples in more detail, and we'll talk about the intuition here, and then we can go to coding. Okay, so we looked at our basic examples. Now let's look at one more in depth and figure out how we actually want to solve this problem. So we have our nested list here, which contains 1, 4, and 6, right? And we need to flatten this into 1, 4, and 6. So the way that we're going to do this is we're actually going to use a queue, which is going to contain the elements that we need to process. And we can just initialize this queue with our initial nested list. And we're going to process the queue from start to finish. So what we're going to do is we're going to put into our queue these numbers here. So 1, and then we have our list 4, 6. Can I make this bigger? Yeah, 4 and 6. And we just want to process it item by item. So what we're going to do is we're also going to have a result function here. Sorry, not a function, a list. And we're going to pop an item from the queue. So we're going to say queue, we're going to pop the item at the start of the queue, and we're going to get it, right? So it's a 1. If this is an integer, then we know that we can just put it into our results because we don't need to flatten anything. So we're just going to put 1 in here. Now we go to the next item, 4 and 6. So sorry, this should be in a list. So what we need to do is actually process these items. But how do we do this? So if this is a list, then what we need to do is we need to actually get the items inside the list and add it back into our queue. So when we pop from the queue, we get this list 4 and 6. And we remember from our example that there's a method that allows us to get the items in a list. So what we want to do is we basically just want to add them back into our queue. And this time the queue will now look like 4 and 6. So then we can continue processing. And now when we pop from our queue, we will get the 4, which we know that we can just work with directly. We'll just put it in the results. So now our queue will just be 6. We need to get the items inside of the list and repopulate the queue. So we're going to say queue equals to just 6 this time, because our method will just give us the items inside of a list when we call it. And then we have queue equals 6. We can process it again, pop the 6, and then we have 1, 4, and 6. So that's basically the general thing we want to do. We want to have a queue here, and we want to process that queue from left to right. When we actually reach an element that we've popped from our queue that is a list, we need to get the values of that list using the method that's provided to us on the nested list class. It's actually already defined for us. And what we want to do is we want to add back into our queue the result of some sort of DFS to flatten the queue, right? So we're going to have a function, and we're just going to call it recursively. So when we hit this value here that it's a list, then we want to flatten it and then add it back into the queue for processing, and we should be done. So essentially we need to set up a queue and do our DFS when we actually need to flatten something. So the DFS function will be the kind of crux of this problem, but it's actually really easy to implement. So without further ado, let's go to the code editor and do that now. Test. Okay, we're in the code editor. Let's type this up. Before we do, I just want to clear away some of this auto-generated stuff by Leetcode. I just want you to see that we actually have access to an isInteger method, a getInteger method, and a getList method. And the isInteger will return if it's a Boolean, we'll get the integer if it's an integer, and it will get the nested list if it's a list. So I'm just going to clear this away to make it easier for you guys to see. Okay, cool. So now we just have our kind of class skeleton. So the first thing that we need to do is actually define some of these methods. So the easiest one that we're going to do is we're just going to do the init one first. And what we want to do is we want to say self.queue. So this is where we're going to be storing our queue of items, is going to be collections.deck. So this is how we're going to get our queue. And we're going to call a flatten function, which is that DFS function we talked about. And we're going to pass in the nested list. So now what we need to do is actually implement our flatten function, which is really the crux of this problem. So let's do def flatten, and this is going to take in our nested list. Now what we want to do is we want to say the items for us to flatten is just going to be an empty list. And what we want to do is we want to say for item in nested list, we need to check whether or not that current item is an integer or not. And based on that, we can continue forward. So we're going to say if the current item, whoops, I can't type today, if item dot is integer. If it's an integer, what we want to do is we want to say items dot append that item, right? Item dot get integer. So if it's an integer, we can just put it into our items directly. We don't need to do any sort of further processing. If it's not an integer, that means it must be a list. And if it's a list, then that means that we have to flatten it before adding it to our values here. So what we want to do is we want to say items.extend. So essentially what we're going to do here is we're going to extend the items that we have here by whatever the result of flattening our nested list is, right? So we're not using append because append will actually add a list literally when you want to add it to another list, right? So if we had a list like 1, 2, 3, 4, and we wanted to add the list 2, 3, 4, if we did append, it would actually append it as a list. So it's like 2, 3, 4. Whereas if we use extend, it will flatten everything from inside and just add them one by one. So this bit is necessary. So we need to use extend in order to not get the wrong answer, right? Because we want it to be a flat list with no nested lists inside. So this flatten bit here, obviously we're calling it recursively, so we'll recursively flatten it. Remember the case where we had like a list of 4 and 6. We would get this list and then we need to flatten 4 and 6, and then basically what this would return is just 4 and 6 together in a list. So we want to flatten it, call it recursively to get rid of any kind of like child lists in there. So that is that. Once this for loop ends, then we can simply return our items and we're good to go. So now we need to implement the next and has next method. So the next is really easy because we've put everything into our queue and it's already been flattened actually. So we just want to say self.queue.popLeft, and this will just get the next item from our iterator. Now what we want to do is we want to say return, for the has next one, basically, is there something else to pop? We want to say if the length of our queue is actually 0, right? So if there's a next, then the length of the queue will not equal 0, and that's really all we need to do. So let me just run this, make sure I didn't make any silly bugs. Judging, let's see, is integer, is it called wrong? Oh, sorry, this isn't nested list. This should be nested list.getList. Yeah, that's the weird thingy here. Now it should work. Has no attribute get list. Huh, did they change the definition? What happened? Let's see. Has next, int next. What did they call it? Ugh, okay, let me reset this real quick and see what they called it. Is integer, get list. Huh, why is it not that? Nested list. Oh god, it's item.get list. Lol. Okay, there we go. Let's see. Now it should. Wrong answer. Great. Oh wow. Okay, I am all over the place today. We need to return something from here, of course. There we go. Okay, well, as you can see, you sometimes make mistakes. And now if we submit it, it should all be fine. Yeah, there we go. Okay, that was a bit embarrassing. Whatever, we fixed it live. Sometimes you need to debug your code live. Good, realistic practice. So what is the time and space complexity? So let's do the easiest one first, which is this next function. Obviously, all we're calling is pop left. To do this from a queue is always going to be big O of 1. We've paid the time complexity cost upfront by doing the flatten in the init function. So this part is just constant time. Obviously, checking the length of it and whether it equals to 0 is going to be also constant time. So this one is constant time. And then we get to init. So the time complexity here, obviously what we need to do is we're going to go through every element in our list and we need to process it. So this is going to be big O of n, and we need to do this up front so we can basically flatten the list. So however many elements we need to process will depend on the size of the list. So it's going to be a big O of n operation. And for the space complexity, obviously we are storing everything in our queue here once it's flattened. So this part will also be big O of n, and we pay those costs up front so we don't have to do it later on. So in the next function, we can do it in constant time, and has next is also constant time. So that is how you solve this problem. There are many actual solutions to this problem. This is just one of them. I quite like this one because it's really easy to follow, and it's like a nice kind of DFS doing it recursively, and it's quite intuitive. Hopefully this video helped you. If it did, why not leave a like and subscribe to the channel if you want more content like this. Otherwise, thank you so much for watching and have a great rest of your day.